Alrighty, so if you're here right now, that means that you have already watched the Good Morning video, my first video, and you've also watched the Brain Pop 4-minute video previous to this. So now we're in number 1, part B, where we're going to take some notes on similar figures. So I had said make sure you had lined paper, some colors possible, pencil to write with, and your packet that you received from your crew teacher today right by you, ready to go. So go ahead and take your paper right now and write down similar figures and characteristics. So we're going to talk about on here with notes, there are 3 characteristics specific to similar figures that you need to be aware of in order to understand how they work. So the first one here is your similar figures have to be the same shape, but different sizes. Same shape, but different sizes. And so I'm going to draw an example. So if I give you a smaller rectangle, and then I'm going to draw one right by it, only larger. And I'm just going to color these both inside. I'm just going to color both of these orange. And just indicating that they're the same shape. They're both rectangles, right? Like that's not changing at all. Both rectangles. But the sizes are different. Okay, so one is smaller, one is larger. That's it. Okay, and as we do this, as we go through the notes, you can pause. Your teachers can pause along the way if you need to just if you're trying to catch up and write things down. That's totally fine. So the second characteristic, your similar figures have corresponding sides. Corresponding sides. Now there's going to be a few things I need to talk about with that. So we're going to call this letter A to start with. So corresponding sides are in proportion. Corresponding signs are in proportion. So we're going to draw an example there of what that means. So I'm going to draw a smaller triangle. And a larger one. And I'm going to label them. So I'm going to call this smaller one A, B, C. And the larger one D, E, F. And I'm also going to put side lengths on these. So I'm going to say in this smaller triangle here, you have sides of 2, 3, and 4. And I won't put measurements right now. And on the larger one, we're going to say these are 4, 6, and 8. So when I say that they're in proportion, the corresponding sides are in proportion, what that means is, with one of my highlighters right now, I'm going to highlight right here, side AB. So when you look at the larger triangle, the side that matches that on the larger triangle is DE. AB, that side, corresponds with the side DE on the other triangle. So I'm highlighting those both yellow. Those match. Those are in proportion to each other. I'm going to use another highlighter. I'm going to talk about how side BC on the smaller triangle is in proportion or corresponds with side EF on the larger. And one more highlighter I'm going to use here. Side AC corresponds with side DF. And so I'm highlighting the matching sides, meaning if I take this smaller triangle and pick it up and place it right on top of the larger one, AB is going to match DE, BC is going to match EF, AC is going to match DF. So that's what it means as far as matching corresponding sides. Now, in proportion, what I'm going to do right now is just show these as a proportion and how they're equivalent to each other. So the side of 3 here on AB matches with the side of 6 here, DE. And I'm going to highlight that yellow. Those are my corresponding sides. And then let's say I set that proportion up to just another group of sides here on these triangles. So let's say 2 and 4. I'm going to highlight those pink. Okay, so it matches the picture. So 3 matches with 6, 2 matches with 4. What I'm going to check right now is their cross products and see that they're equivalent, and it creates that proportion. 6 times 2 is 12. 4 times 3 is 12. Yep, absolutely. When they're equivalent to each other like that, you have a proportion. Those sides are in proportion to each other. Let's try another one. So let's this time I'll pick side AC in blue, that's 4, and match that with side DF, that's 8. I'm just going to color that blue. And then I can pick any other side in those triangles to match and see if they're in proportion. So let's say maybe I go again with the bottom here, BC, which is 2, EF, which is 4, in pink. And so if I want to check their cross products again, let me get this, see if I can zoom in a little bit better. There we go. So 8 times 2, 4 times 4. 8 times 2 is 16, 4 times 4 is 16. So when you see that, that verifies for you again that that smaller triangle, its sides are in proportion or corresponds to the larger triangle. So that is one way you can look to see if you have similar figures. Now, another possibility with corresponding sides, I'm going to call this letter B. And I'm going to write growing or shrinking by the same scale factor. I'm going to underline the word scale factor. Growing or shrinking by the same scale factor. So I'm actually going to redraw these same triangles down here. And I'm just going to put the sides on here right now, like this. Okay, so it's the same triangles as above. All I'm doing is labeling the sides. And let's take a look at what scale factor is. So let's say I look at side 3 on the smaller triangle that I know corresponds to side 6 on the larger. From this 3 to this 6, those matching sides, how much larger is that getting? What is it getting multiplied by? Well, I hope you see that it's getting 2 times bigger. This is getting 2 times bigger, times 2, times 2. Well, is that the same all the way around? Meaning, can I come down here and look at 2 and 4, and from this side 2 going to side 4, is that also scaling by 2? Is that getting 2 times bigger? 2 times 2 is 4, yeah. That's also growing by a scale factor of 2. And you can check the third side, right? So if you check 4 and 8, yeah, 4 times 2 is 8. So you can check by its scale factor as well. All right, so far, let's just see what we've talked about. Characteristics of similar shapes. Same shape, but different sizes. Second, corresponding sides. So for them to be similar, you can see if they're in proportion like we did here. And you can also see if they grow or shrink by the same scale factor. There's one more thing with similar figures, and this is going to be number 3. And again, you can pause if you need to the video and finish copying down. And so I'm going to turn and do number 3. Okay, the third item, a third characteristic for similar figures, is that corresponding angles are congruent. Corresponding angles are congruent. So I'm going to draw some triangles again. Now remember, congruent means equal. Okay. So I'm going to draw the ABC triangle like on the front. A, B, C. I'm going to say this is a 90-degree angle in the corner here. And then I'm going to draw a larger triangle and call this DEF. And that's also going to have a 90-degree angle there. And then what I'm going to do is I'm going to put this angle marking, a single angle marking, in angle C and angle F. And at the top, at angle A and angle D, I'm going to put a double angle marking there, like this. So corresponding angles are congruent. So what that means is this 90-degree angle matches the other 90-degree angle. Those are both 90 degrees. If you want to even write that in, you can. You know that that square means 90 degrees, but you can write that in. Their angles are the same. Over here, angle C and angle F, let's say that those are 30 degrees. And lastly, up top here, the top angles are 60 degrees. So the angles are the same. They're congruent in similar figures. Okay, so again, if you have to catch up, right, pause the video, go back, whatever you need to do to make sure you have those notes. And then the next thing that we're going to look at is your packet that you got. So in that packet, We're going to look at the first page. So when you're set, you can take your notes, kind of just push them to the side if you still need them while we do some of the packet. And we're going to start with the first side again of that packet that you have from your crew teacher. So I will meet you back here with that packet.